Greetings. Today we're going to model the Josef Hartwig's 1924 Bauhaus chess set. Bauhaus is one of the, um, definitely a top 5 most important design groups in all of history. This chess set to me is no different. I think it's an amazing chess set. I am a super big fan of the Bauhaus. I used to pour, when I was an undergrad and in grad, just poured over those books nonstop, and I still do, checking out their work. It's so great. It's so beautiful and so elegant. Um, so we're going to model all of the Josef Hartwig Bauhaus chess set, but today we're going to model just the bishop. The bishop is the hardest one, so I thought I would give you an introduction to Tinkercad and 3D printing using the bishop chess piece because it's kind of the trickiest one to model. Okay, here we go. On our left over here, let me move myself out of the way. On our left over here, we have Tinkercad, and on our right is my Google Doc with all the steps and stuff that we're going to use. So this doc is called Model Bauhaus Chess Pieces in Tinkercad. I'll put a link to this Google Doc in the description or in the comments of the YouTube video, just so you can easily get to it. Definitely overview this because it has all the stuff you're going to need to do for the assignment. Okay, this is the Bauhaus chess set. From 1924. There's a 1923 version that's slightly different. I'm a fan of the 24 version. And I have some links here to give you better images of this. This is the chessboard and the box, which is also completely beautiful. So I'm going to I have these already open, so let me go ahead and flip over to these. This is a great view of the chess set itself. This is one for sale. You can see that it's $376, so you can make one yourself. This is a zoom in of that image, and this is the piece we're going to make right here. One thing to notice, this is the correct orientation for this piece. You will see in a couple other photos online and stuff, this piece, for some reason, gets put in the wrong position, and I'll show you. Do you see it right there? That is not the correct orientation, just as a heads up. Anyway, we're going to model this one. It's an X with a sort of 45-degree bevel on the end of each X. Okay, and I have given you dimensions on all these pieces, and our dimensions are always going to be in millimeters, and this assignment's no different. The bishop is going to be 30 millimeters high by 30 millimeters at the base, so 30 millimeters depth and width. And I gave you a note here that the arm width of the X should be 8 millimeters, so this little arm width right here should be 8 millimeters across. Okay, so not too complicated, and we're going to need 2 of them, right? Because with chess pieces, you have 2 of this piece here and here. You have 2 of this piece, your knight, here and here. You have 2 of your bishop here and here. And then you have a queen and a king. And again, this is called the rook. Sorry, I missed the name of that. And these are your pawns. Oh, and just a side note, the cool thing about the Bauhaus chess set is the pieces show you how the pieces move. Rooks can move any direction forward or any direction to the left. Knights move in this L shape, so 2 over and 1 across, or you can also go 2 across and 1 over, but this L shape is what you're doing. The bishops can move diagonally, or so it's an X shape. A king can move any direction, but in one square only, so it has the square head. The queen can move any direction, any number of squares, so it has the most nimbleness and flexibility and power, so it has the sphere on the top. And then this is our same over there. Okay. This is Tinkercad. Over here on the left, Tinkercad is a great tool. If you've never used it before and you're new to CAD, it's a really great introduction. It's made by Autodesk, the same people that make Fusion 360. I think Autodesk just calls Fusion 360 Fusion. So if I say Fusion 360, it's the same thing. Sorry. Tinkercad is kind of built for everyone who wants to get their hands dirty with CAD but have never used a CAD tool before. It's sort of somewhere in between the user interfacing of Blender and the user interfacing of a CAD tool, and I'll talk about that as we go. But this is it. Notice Tinkercad gives you just a generic file name for new things, so don't read into this too much. You're just going to always get one. These are your basic shapes over here on the right. Notice these two here that look translucent like ice cubes. These are hole shapes, meaning these are how you add holes into other shapes. So we'll be using those. I'll walk through the other tools as we use them. So here is a cube. You can just grab it and drag it in. And you'll notice what we're getting is a 20 millimeter cube. And it's 20 millimeters on all sides. This box tool right here is extremely useful, I think. It's the fastest way to set your sizing. So we need 30 millimeters on all sides. So we're going to do 30, 30, 30. Boom. Easy, right? That's by far the easiest way to change the size of an object, especially if you know exactly what size you need. There's a couple other ways to do it, though, so I'll show it to you. So you could do this. We're at 20. I'm just going to move this out of the way. You could grab and go 30, 30. Now, you've only gone 30 in two directions, this way and this way. You still need to go height. So you see how your height is currently 20. So another way you could do it is just click on the direction you want to go, click on the number, type 30, hit enter, and you've gone 30. Now you can check that. Now notice we're in the top view here, but let's go to the side view, or sort of top left view, and you can see here everything is 30, 30, 30, and it looks square. That's good. Another way to do it, oh no, that's all the ways to do it. Just to recap, clicking on the direction you want to go, changing it, right? Or changing it. Okay, so just double checking. We're at 30, 30, 30. Okay, great. Now, what we want to do is we want to make this X shape, and we want this little piece right here to be 8 millimeters. So what I'm going to do is I'm going to take 4 cubes. I'm going to make a plus sign. There's a couple ways you can copy and paste objects. You can do it the classic way, which I'm on a Mac, so I'm going to do Command C, but if you're on a PC, do Control C, so I'm going to do Command C, Command V, and I just pasted one in. Cool. Or I can hold down the Option key and drag a piece, which I'll do there. It's super quick. And now we have our 4 pieces, right? Pretty cool, pretty cool, pretty cool. Another thing you can do is if you want to change your view, this is orthographic view here, and this is perspective view. I quite like perspective view if I'm trying to be precise. I find it's just really helpful to kind of keep my 2D brain going when I'm in top-down view here, and it makes it kind of straightforward. So I'm going to leave it in orthographic view, but you'll start in perspective view, which is what this is, and that's cool too. Okay, so what we're going to do is I just move this 8 arrow marks up. 1, 2, 3, 4, 5, 6, 7, 8. Let's take the ruler. So we set our, that's the ruler tool. Sorry, so the ruler tool is kind of freaky, but it's also pretty powerful. So what I did is I took the ruler tool and I drug it into the lower left corner. Notice when I drug it into the lower left corner, it has a sort of red outline, and that's what you want. What's cool about the ruler tool is you can see here, we know immediately what our dimensions are on this square. So I'm going to go here. Aha, yes. And do you see this right here? This says, well, this piece starts at 38 millimeters past the 0 point. And so we know 8 is our gap. That's great. So we also know if we click on a thing and we use our up and down arrows, we're moving it a millimeter at a time. Really useful. Okay, so next what we're going to do is take this square, and what we want is look at our green bar down there. If it's at 31, we know we're 1 millimeter too far. So we're going to go to 30. Boop. And now we can do 1, 2, 3, 4, 5, 6, 7, 8, and we know we're at 38. And now we're going to take this one, and we know we're at 31. We want to be at 30, right? 30 is our green. And we want to go 8 over. 1, 2, 3, 4, 5, 6, 7, 8. And now we have a plus sign. And if we switch back to perspective view, you can see here we have our, it's 4 cubes, right? But it's really useful to look at them just as like flat. objects. Okay, so now we're going to take and make a fifth one. So let's take this fifth one, and what we want to do with this fifth one is we want to rotate it, and we want to rotate it 45 degrees. This is your rotate tool here, and I'm going to show you there's a couple of things to know about this. It's quite powerful and quite good. The first one is this. You can see here it's moving 22.5, and then there's a little tick mark on the rotation widget. Boop, 45, right? That's what we want. But if we went again, boop, 67.5, and again 90. What we want is 45. Now, if you want to get more precise than just these 4 tick marks, pull your mouse out to here, and notice you get a smooth rotation, which is quite useful. So if you want 44 or whatever, that's how to get it. But we want 45, so we're going to go to 45. I really love that they did that. It's really useful. Okay, so oops, sorry. So we're at 45, and now what we want to do is we want to drag this to the middle. I think what we want to do is move this then to right here. And let's take a look at that in perspective view and see how that looks. Yeah, it's looking pretty good. I'm gonna go back to ortho view, hit top to like orient myself back to the top. And now here's what we're gonna do. Now you can notice this is the shape we want right here, right? It looks like this shape here. So what we're gonna do is we're gonna get rid of these hunks here by clicking on these 4, selecting whole. Boop. Now, one thing to know, when you make this a whole shape, it's still a shape, it's just called a whole, right? But what we need to do is we need to group, Tinkercad uses the word group. We need to group all these shapes, and when we group our whole to our shape, it's gonna cut a hunk. It's gonna scoop this hunk out. So I'm gonna go ahead and hit group, and you can see now we have our bishop shape. Pretty cool, right? We did it. Not hard, but you know, if you have little tricks, sometimes it can really help. If you try to model this on your own without doing that, you would be a little bit bummed. So, okay. So now what we need to do is, let's go ahead and just make the view cooler looking, right? What we need to do, I'm just going to show you something really quick. So now again, we can duplicate it, right? So let's imagine you modeled up a few things, but you just wanted to export one of them to your 3D printer. What you'll do is you want to make an STL file. And so click on the shape that you want to export and use the export button here. And what you want is STL right here. There's reasons you might use OBJ or GLB. For laser, you're going to use SVG. If you wanted, again, to export out to Fusion, you could do that here. But all we need is just an STL file. And the reason I'm showing you this in detail is this reason right here. When you click STL, notice it used your file name up here. It doesn't name each piece or anything like that, so that can get kind of confusing. So what I would do is just go ahead and flip that right now and call it something like Bauhaus Bishop. That way you don't break your brain wondering what that is. Cool. Now we're going to take this STL file and we're going to bring it into our slicing tool and 3D print the thing. That's it. Hope it was cool. Sorry I blipped out in a couple things. You always get when you're doing a lesson, something always goes sideways, or you're like, how does that work again? Self-doubt, it really gets you. So anyway, hope that was useful. Actually, I'm just going to get rid of these. Again, just using the delete key, we'll get rid of them. And I'm going to change this right now to Bauhaus Bishop. That way I know what it is. Awesome. Hope that was useful. I will see you in the Bambu Slice tool. All right, you're going to open up Bambu Studio once you've got it installed. I'm on a Mac, so it's in my applications folder. If you're on a PC, it's going to be in your programs folder, I suppose. And let's go ahead and do a new project. And you're going to see a bunch of settings here, and I'll give you a little overview on what all those look like and do. I have a printer up here. This is the Bambu Lab A1 Mini. You'll need to add a printer in here, very likely. This can be a little tricky, so give me a shout if you get hung up doing that. This is the print plate. This is a textured print plate on top of the Bambu Lab A1 Mini. This plate comes with that A1 Mini, so chances are this is the one you'll use, but if you have a different kind of plate that you got from Bambu Labs, use that. Diameter is 0.4. That's the standard nozzle we have on the A1 Mini, so that's great. We're using PLA Basic material in the filament in the printer, and so that's fine. We're going to leave that as is. All this is fine. Our layer height is fine. If we were doing something fancier, we might adjust the layer height, or if we want to do something rougher and get it done quicker, we would increase the layer height as well, possibly. But so yeah, the more accurate you are, the longer it takes. The less accurate you are, the less time it takes. Seam position is fine for now. Advanced is fine for now. And what we're going to do is go into our exports, if I can find it on my drive. Wrong thing, exports. And this is our STL file. So we're going to go ahead and drag it onto our print plate. And we're going to use the slicer built into Bambu Studio. Other people use different slicers, so they're great. But for now, we're just going to use the one that's built in. A couple things. So I just drug this onto here, but we're not completely confident that's actually sitting on the plate. So do an auto orient just to make sure your model is actually down on the plate. Also, auto orient will hook you up if there's a better way to position your model on the plate itself. Add plate here is a little mysterious. You can have multiple plates. So let's say you have a project that's got 6 different pieces that all need their own separate plate. You can sort of set up a project and have kind of multiple things in there. You can have also Bambu Labs arrange stuff in here. So say you have a whole bunch of stuff and you want it to like be arranged in a time efficient and tidy manner. It will do that. Variable layer height here is an option that will actually adjust your layer height from the bottom of the model to the top. This is quite handy with spheres. We'll talk about that later on. Spheres, you want the top layers to be quite small so it looks good, but we don't need that for our purposes, so we're going to turn that off. And yeah, if you need to rotate the model or do anything like that, you can. You can scale it here. I don't totally recommend that unless you're in a pinch. You can scale it here. Let's say you use some other tool like Maya or something like that. You might need to scale it. Lay on face, we're going to ignore for now. And let's go ahead and slice the plate. So we have we've sliced the plate, and slicing does exactly what it says it is. It's slicing the model up into different layers. So each of these layers can be printed one at a time. You can kind of think of a 3D printer as like a glue gun, right? Like kind of squirting a layer down, or like a cake icing that you're just going to build up, build up, build up, build up. You'll notice here you've got this really long bar here and this really long bar here. This little bar right here is showing you the path that it's going to squirt out the PLA plastic on. Notice this path is just for this single layer on the top. All this gobbledygook over here is what's called G-code. That's the actual commands that the printer uses. This is your layer height. So you'll notice here we've got 27 minutes and 23 seconds worth of layering to do. We've got 150 layers. So you can see now it's going to go all the way, what the first layer is going to look like, and then as we go. Notice right here, right, it doesn't make a completely solid object because that would be wasteful. It would take a long time. And it's not necessarily going to give you a better print if it's solid. It could be kind of squishy at the edges and stuff. So this is what's called infill. You can set your infill percentage if you want something to be more rigid. You could give it more infill if you want it to be lighter weight or print quicker. You can give it less infill. But this is kind of a visualization that goes all the way up that shows you all your prints, which is really cool. Also, you have a view cube up here, which is just like in um, other 3D applications, uh, um, like Tinkercad or something like that, or Blender or something like that. So you can use the view cube to like check stuff out, check your model out, make sure everything is cool. I kind of like this front left view. All right, so let's go ahead and print the plate. Notice right now it's telling you that it understands the printer. It's going to send this STL file over Wi-Fi to the printer. If this, for some reason, isn't connecting for you, sometimes you have to restart Bambu Studio to get this to work correctly, even though they have this kind of reload thing here. I've had that short out sometimes. This is just telling you what the PLA is in here, which is good to know. Auto bed leveling's turned on. Time lapse. Let's go ahead and turn time lapse on. There's a mini camera inside the Bambu Lab A1. It is not a high quality camera, but it's kind of nice to see the time lapse. And so it'll store the time lapse on the SD card built on the printer. And let's go ahead and hit send. So now we're in the device view up here. We were in the prepare and preview up here before. It's now downloading. It's 100% downloaded. You probably hear the printer turn on. The heat bed preheats. Just a reminder, you should always clean your heat bed with an alcohol swab or something like that before you print, just to make sure there's no dust or anything weird on there. This is a view of your PLA spool, which is nice. You can unload and unload the spool from the software right here if you want. You can also do that on the touchscreen of the printer, but some people like to do it from here, particularly if their printer is in another room or something like that. It's checking vibration compensation, so it vibrates the motors and makes sure the print doesn't get messed up by the motor speed. And we should be printing soon. I just turned the camera on with this little option here. And I'll switch over to the other camera view so you can see the print. Okay, this is the Bambu Lab A1. You can see that sort of bronze plate there. That's our magnetic build plate. That plate does pop off. You can see a little bit of like residual on the front. It prints that out just to sort of check its print line. And here we go. This is the very first line being built out. You can see it's doing a second round, cleans the tip off, and now it's doing an infill. You can see it filling in back and forth, back and forth, back and forth. It's going to do this all the way across. And I think it's going to do it a second time and possibly a third. Again, this is just to create a solid layer on the bottom of our piece and also give it some rigidity. Okay, it's outlining it again. As you can see, I sped up the recording so we don't all fall asleep. Doing a second infill, full infill layer. Again, this is quite sped up. Third. And now we're filling in the third layer. And soon we're going to start seeing the infills come in, and it's a sort of honeycomb looking infill layer. Yeah, here we go. So now if you look, you can see it's not filling in the entire thing. It's just filling in this kind of honeycomb or kind of grid shape inside. So this is drastically sped up about a few thousand%. Just so you can see these infill layers getting built out. And then what's going to do is what we did at the bottom is now going to happen again at the top. So we're going to fill all the way in, which you can see here. It's sort of like icing a cake. And we're going to get another layer in. And that's about it. Okay, we're pulling our print bed up. It's magnetic. Be warned, it can be quite hot, so definitely check before you do that to make sure it's not hot. I let it cool down a little bit. If you hear that popping sound, that's the printed piece disconnecting from the plate. The plate is designed to flex. Don't over flex it, but you can definitely flex it like I am right now. And there's not a lot of surface area touching the plate, so I didn't use a scraper or anything like that. Notice the build plate is keyed, so it only fits back onto the printer one way. Okay, you can see here we've got some issues with our print. You can see what looks like is happening is the print nozzle is leaving the print a little bit early. And so we're getting those unfilled holes and also the little dots next to them. There's some ways to fix that. Also, you can see there's a couple of lines that are a little bit out of whack. Also, if you look really close, especially on the far right there, you're getting some of the lines aren't totally adhering. So we're getting under extrusion right there. All of these are fixable a couple different ways. They're fixable manually, and they're also fixable in your slicer settings. We're going to pursue the manual fix for now, but we'll definitely talk about how to fix stuff in the slicer as well.